Another aspect that I would like to talk to you about is the utmost ceiling of the advancement of artificial intelligence. Building a super intelligence. That
Hmm.
entire conceptualization, that's what I would like to discuss about with you right now. What are your opinions? How far are we till we reach that point where AI sort of becomes sentient? Like we are able to actually build a synthetic consciousness, possibly.
I don't have much knowledge about all of these things, but I could just tell you one thing, which I have heard of is the company Quantinium. I don't know if you've heard of, and the Oxford. What these guys? So there is this professor, not professor, like he's a scientist now, Bob Cook. He's in also Quantinium, and I think I have heard from one of the person who has worked with him that this Oxfords and everyone, they're just trying to look on this something called as quantum consciousness, of how we could map consciousness into a quantum processing units, because there is a field known as quantum natural language processing, which tries to harness the whole stuff. So uh, in the same regards, like they are trying to map how can we map consciousness onto AI, and since these are whole as a quantum processes, they are trying to put it in that term. So can we have a quantum consciousness? And maybe that could be an answer to the whole thing, because as per my knowledge, there is like a lot of research that is need to be done, even in regards with the classical systems and all. And as one article says that our brain is a quantum computer, well then maybe it's like the consciousness also can be mapped through that thing. So yeah, maybe a quantum computer would help in that.
What are some other applications of quantum technology or quantum computing? Like I would like for you to talk about probably drug discovery, or maybe you know different other applications, probably in a little bit of detail to actually have the viewers get an idea about the actual impact that the quantum technology can have on the society at large.
Okay. So basically, right now, whatever algorithms which we are using and having there in classical, they come to a saturation at a point because of this large amount of data, and there is a exponential time that is required to process all of these things and stuff. So right now, the quantum computers could be very much utilized towards this. Firstly, the optimization problems, in which one would be like the one which I sold the example of the Uber, of optimizing the path. Oh, then there could be maybe like handling the air traffic, uh, designing engines. So there's a company known as Boson QSci, which I have worked with as an intern before. They work on this computational fluid dynamics, and they are working very well on this quantum algorithms uh, for this dynamical processes. That is where it is also going to be helpful. Then the second lead could be like in material sciences, of uh, why we struggle of understanding, like as Dr. Feynman said, that if we want to replicate the world, let it be quantum, not classical. And that's where the quantum computing comes in picture. It's like we can simulate the quantum processes on an actual quantum hardware where it could actually behave in that similar fashion. That's where the drug discovery comes in picture, or various material science applications comes in picture. I think like this is one of the most prominent thing which right now the whole world is working, because we see that even if we have Google's AlphaFold and stuffs for protein recognitions, and there is still a lot of aspects to work on, and that is where the quantum computer is going to take come in picture. uh, so I think I see right now is just this algorithms which it is trying to work on, and that is where the whole application is. It's going to be in a broader aspect rather than solving simple things in life, because well, classical computers are already solving those things. And uh, that I think that will be like, I'm not sure if ever a quantum computer will come into the classical picture, but hope I'm not, don't know, it's a very wide research, and it's very difficult to predict the future.
You did mention about the inclusion or the utilization of quantum computers in the aviation or aerospace sector. Uh, could you elaborate upon it? Like, in what specific ways is quantum computing or quantum technology probably contributing towards the betterment of our current know-how in regard to aerospace?
Okay. So right now, like when it comes to in these fields, what we see is all the models which we build. So I'm giving a very broad aspects of this, but any models which we build are again based on some partial differential equations, and finding the solutions of this partial differential equation is not that easy. It's not that trivial to get into. So here's where the quantum computer comes in picture. It tries to solve this kind of an equation. Like, we have various classical algorithms, but the solution is not an exact solution. It's again an approximate solution. So quantum computer over here, like, we believe theoretically that it is possible to achieve a global minima, or something. I'm not talking in a very deep kind of thing, but it's like it can find a very proper solution towards this partial differential equations. So that's how it's going to take in picture in terms of aviations or other things.
Do you know about Gravity Industries?
Gravity Industries now.
I'm going in a little bit of side tangent, but since we were talking about aerospace, they basically Richard Browning is the CEO. The last I read about them, and their entire purpose is to sort of scale down the aviation technology to replicate flight systems for individuals, like jetpack technology, sort of, but a little more advanced in ways. And my point with going onto this side tangent is how the end purpose or goal of any technology is to sort of scale it down in terms of its physical size. Like with classical
Okay.
computers, when it started in the 1900s, they were bulky and huge and everything. And today it's like we have palm tops and our mobile phones, right? We have Apple watches. With Meta, they release their lenses, smart glasses, Google. And as we move forward, currently quantum computers are bulky and huge and hefty, but there will inevitably come a point where possibly we might have quantum personal quantum computers. My question to is, we did talk about how classical computers already are capable enough to satiate our current requirements, day-to-day requirements, and quantum computers are good for explicit specialized problems, but not necessarily the generic day-to-day tasks. If we are to reach a point in time where we have these personal quantum computers, what would they be used for, if for anything at all?
It's completely depends on the fact that, like, firstly, your classical computer also works on the basis of quantum mechanics, and the only thing is it works on a simple information theory rather than quantum information theory. So right now I don't see the point of, even if we have a personal quantum computer, maybe at most for gamers it will be like, oh, much faster processing unit. I can run a game in a very more realistic manner because it is able to find the equations much, like solve the equations, vector equations very faster, and process the holographics very faster. Yeah, that could be a there. But then maybe it's like, I don't know, if I want to use an MS Excel sheet, I don't need a quantum computer to do so. In my classical computer, and an i9 processor is very very fast to do so, and it's very helpful.
I mean,
So
they could be more of use, uh, probably in for astronauts maybe, or people who are working in extreme conditions, like astronauts. They are in space, right? They might be able to utilize more and gain more benefit from using quantum computers. Maybe if we reach the potential or the uh, point in time where we are able to, where things like interstellar travel and multiplanetary mutation, it's day to day normal things. They might be of use in that regard, like in those extremities. But I think I understand day to day lives for people, for a normal person, quantum computers might not really change much.
yeah, unless there comes a product which actually is something which is very unimaginable, and it's like, who had ever thought that there will be existing something called as a mobile app. Okay, and that could revolutionize things. So this is a very very interesting research, and it is going to take time. But yeah, if it could do something, it's again, we are reducing the latency when we come to the point of accessing the quantum computer in hand or in person. Right now, even as everyone can access a quantum computer, it's like it's accessible through the cloud. You just need a classical system, as a good internet connection, and proper timing to access a quantum computer. So yeah, I think current day-to-day scenarios, a classical computer is solving it, and it's like I'm myself, I'm happy with my mobile phone doing so many things. So yeah.